Have you ever found yourself confused about which integer type to use in Julia? It can be a bit overwhelming, right? If you're wondering whether to declare your integer as a general type or a more specific one, you're in the right place. Today, we're diving into the differences between abstract and concrete types in Julia, specifically focusing on integer, int8, and int64. I totally get it. Choosing the right data type can feel like a daunting task, especially for newcomers. You're not alone in this struggle. Many beginners face the same dilemma when trying to optimize their code for performance and style. Here's the specific question we're addressing today. One user asked, should I declare my integer n as integer, int8 or int64 if it will only ever take values between 0 and 10? This is a great question that many new Julia users have. Let's explore the options together. So what are the differences? Using integer is general and flexible, but it might not be the most efficient choice. On the other hand, int8 and nuances are more memory efficient for small ranges, while int64 is more suitable for larger numbers but can be overkill for our case. Let's break this down further. And stick around. At the end of this video, I'll share a pro tip that can help you make the best choice for your coding projects. To begin with, the user should consider the range of values that the integer will hold. Since the user mentioned that the integer will only take values from 0 to 10, using a smaller type can be more efficient. Next, the user can declare the integer as either int8 or uint8. Int8 allows for negative values, while uint8 is strictly non-negative. Since the user's values are always non-negative, uint8 is a suitable choice. Now let's discuss performance. Using a smaller integer type like uint8 can lead to better memory usage and potentially faster computations, especially in large arrays or performance-critical applications. Finally, while declaring n as integer is more general, it may not be the best choice for this specific case. The user should prefer uint8 for clarity and efficiency, unless they anticipate needing a broader range in the future. Fun fact, did you know that the first computer, ENIAC, used vacuum tubes and filled an entire room? Today, we can do so much more with just a tiny device in our pockets. Now, let's look at the answers provided by other users. This user suggests using int for declaring your integer n, emphasizing generality. They note that while performance is important, you should avoid using int64 unless absolutely necessary. They also mention that many functions dispatch on int rather than integer, which can lead to issues if you use uint8. The key takeaway is to avoid being overly specific with types. That's all for that response. Let's see what someone else had to say. This user suggests that for beginners, understanding abstract types in Julia can be clarified by checking subtype relationships. They found that both int and uint are subtypes of integer, which means they inherit properties from it. Additionally, int64 is a subtype of int, indicating a hierarchy in types. Here's the pro tip I promised. Always consider the range of values your variables will hold. Choosing the right type not only optimizes performance, but also makes your code cleaner and easier to read. And there you have it. Now you know how to choose between integer, int8, and int64 in Julia. Remember, the right choice can make a big difference in your coding experience. If you found this video helpful, please subscribe for more tips. And don't forget to check out our next video for more Julia insights.